Hello, today I will show you how we at Frinx handle the automation of L3 VPN provisioning. The whole process can be broken down into three distinct steps. First step is obtaining the data from the user. In this case, the user might be an operator responsible for provisioning customers with a VPN service. The data is obtained from the UI with which the operator interacts. User's input is then converted to a standardized format. Data obtained this way sit at the service layer, which is the highest abstraction we work with. The structure of this data is defined in a Yang model. This service layer represents the operator's intent and the business logic of a VPN service. Here we can find the metadata about the VPN. For example, what's the VPN's internal name, what's the customer's name, what's the topology of the VPN, but also data about the customer's physical sites, like the address of the customer's offices or which of the VPNs is this particular office connected to, etc. The second step is to translate the data from the service layer to a layer below it. That layer is called the network layer. As the name suggests, this layer contains more concrete data related to the actual underlying network of the VPN service. For example, if there is a VPN access defined, what routing protocols does it use? Is it BGP or static? What's the customer's IP address? What is the quality of service profile? So all these questions are answered in the data contained in the network layer. That brings us to the third step of the L3 VPN automation. Configuration of the actual routers, the network devices that do all the heavy lifting. Data that needs to be sent to these routers is defined in the device layer. The shape, so to speak, of this data is determined by the device-specific Yang models. Here we can find the names of the device interfaces, firewall settings, routing instances, etc. What we did here at Frinx is that we automated the process of provisioning of an L3 VPN by implementing the complex logic of translation between these layers. That might sound easy enough until you realize how interwoven the data is. And that's not to say that for the sake of simplicity of this video, we didn't mention the barrier layer, which also plays a crucial part in the automation process and adds another layer of complexity. Plus, we haven't even mentioned the network resource allocation that is done automatically during the translation process and is provided by our very own resource manager called Frinx UniResource. We will now proceed to show an example of L3 VPN automation from the UI. Let's start by creating a new VPN service. This is a fairly simple example to kick us off. Okay, let's click on this menu icon and navigate to the L3 VPN automation menu. Here we can see the control page with three items: services, sites, and VPN barriers. Let's click on the services item. Here we can see there are already some VPN services created for our imaginary customer. We can click on this drop-down icon to have a peek at each of the VPN services configuration. Let us now create a new VPN service. We will click on this blue button to add a VPN service. The unique VPN ID will be created and allocated by clicking on the chain icon. This will request the VPN ID from UniResource, which is our own in-house resource allocation engine. Once the VPN ID is allocated, we can select the customer's name or insert a new customer. I'm gonna insert one of our existing customers, customer number 1. Then we select the VPN service topology. We can choose any one of these. Then we select the default CVLAN and external VPNs. So the CVLAN can be, guest Wi-Fi VPN, and the external VPN will be MGMT. Okay, we can now save the changes. Then we can once again look at this drop-down menu over here and we can double check whether the data we have put in is actually the data we want there. If it is, then we can go back to the control page, and the control page will actually show us that there is one VPN that has been added. So there is new data on the service layer and we will now commit the data. When we hit the commit button, this blue button over here, we actually fire off a workflow that translates the service layer to network layer, and that network layer to the device layer. So we can check the workflows. Let's go here to the export workflows section. Then we click on the executed workflows and navigate to this first one to render all workflow. Okay, we can see that since we clicked on it, the workflow has been completed and finished. Here we can see all the tasks that the workflow has executed. All these tasks have been completed successfully. Therefore, we know that a new VPN service has been created. Okay, so now we are going to do something more complicated, and that's adding a new site network access. Okay, so let's open up the L3 VPN Automation menu once again. Over here we navigate to the sites menu, and now we have a couple sites over here. So what we are going to do is that we click on this manage site network accesses icon. Okay, and over here we click on the button add network access. Now we are going to fill in the form. So first we have to attach that network access to some VPN. So we choose one of the VPNs. Then we need BMT circuit reference. So I will use this one over here. Of course, we need a device. So I'm gonna use a simulated Junos 18 device over here. And then we are going to choose the QoS profile, and we are going to add static routing. Okay, so we can use this, and the next hop will be 10.0.0.1. The LAN tag, I can choose an arbitrary value. Okay, the BGP profile, I'm going to choose 300 milliseconds, and over here I need to get the provider and the customer address, and that will be taken care of by the UniResource, the resource manager. So I'm going to click on this icon over here, and in the background it will run a workflow which will allocate the addresses for me automatically. And while it's doing that, I'm going to choose the BFD profile, which over here defaults to 500 milliseconds. Okay, so now I'm going to save the changes, and of course now I want to commit those changes to the network and to the device, to the simulated Junos device. So I'm going to go back to this control page and run the commit button. But before I do that, we want to be sure that the changes actually propagated down to the device level. So what we are going to do is that we open up this device inventory over here from the main menu, scroll down until we find the mounted LabVMX device, which is the Junos 18, and we are going to check its configuration. So we can see on the right side, this is what is actually on the device, what configuration it has. And if we scroll down, we can see that this configuration has got 551 lines. And if you go back to the site that has been updated by this network access, we can actually check what address has been allocated for this new site network access, and it ends with 112. Okay, so let's find whether we can actually find an address or any string that is 112. As you see, we cannot, because the site network access so far haven't been propagated down to the device level. Okay, and now we can actually come back to the automation menu, click the commit button, let the workflows do their magic, and we can actually observe what the workflows do. So we're going to go to this executed workflows tab and click on the running. And as the individual tasks of the workflow are finished, we can see them here. Once this is finished, we're going to once again check the device to see whether our changes, our desired state, propagated down to the device level. Okay, so we are finishing now. We are now committing the transaction and closing it. Okay, so once the workflow has finished running, we are going to go back to this Junos device, and remember that we were unable to find string 112, and the size of the JSON was 551 lines. Now we click on this sync from network button, let it do its magic. So we can see that the config is bigger now, and when we now try to find one of the IP addresses that we have inputted in the form, you can see that it is already here and it's registered as the neighbor of that site network access. Thank you very much for your attention.